Okay, good afternoon. Or
I will ask you to speak
very close to the. Yeah. Okay. I'll try to talk quiet and like I said. Okay. Hello, everybody. Like I said in the introduction, I'm Bart from Fluxo. I started Fluxo about I think in 2007, the end of 2007. Do I have to speak up? Yeah. Okay. So I started Fluxo in 2007. It went through several iterations, and by now it's a CE certified device, which already mentioned in the introduction can monitor your electricity consumption, gas, water, etc. And then, yeah, this is going off on a tangent and see what else we can do with the Fluxo. And for that, I would like to introduce the Fluxo Cube. It's something I've been working on. It's very experimental, so it's only like a month old. It's this kind of thing. I think it should sticks to metal like that. And so for a close-up, this is the Fluxo Cube. It's an experiment in trying. Well, what you see in most nodes is that. Especially in open source, we take a microcontroller, an AVR, an ARM, etc. We attach a radio to it, and then we have the basic board, and there are some ports to which you can hook up different sensors, which is great, except that if you want to put this in your living room and it's full of wires, etc., and this won't pass the Wi-Fi acceptance factor. So. That's one thing, and secondly, well, the chances are that it's not going to last very long because a wire gets pulled out, etc. So I wanted to, in this experiment, I wanted to start saying, okay, so how can this thing look? How can make it fully open source? How we can make the enclosure 3D printable? And this is the first, let's say, iteration. So this is really version 1. The enclosure was printed at the Fab Lab in Leuven on Friday. So it just had enough time to cool down and present it over here. So if you open it, it's actually 2 boards. Okay, I'm going to try to coordinate this. So there's a magnet. As you can see there, there's a ring magnet, a neodymium magnet in the back, which does 2 functions. So you can hook it up to anything that's metal. And secondly, there's a battery at the back over here. So it's a fat lithium coin cell battery, 1000 milliamp hours, which also is also magnetic, responds to the magnet. So that means that if you position it over here, it gets snapped back and it will retain there. So if I put it in there back and you hold it upside down, it won't release. So for that, I put a little hole in the back so you can push it out. But this means that yeah, you can just mount it anywhere in your living room, etc. And it will stay put. Now for the node itself. Well, perhaps a bit first about the enclosure. The enclosure was designed in OpenSCAD, which is a great tool for making these kinds of things. So it's basically programming, and you program your enclosure, and you can also make all kinds of everything. You can make it a parameter. So you can say, here, for example, you have it's a bit small, but you can say the magnet dimensions, and I have to have this kind of tolerance, etc. You can see the file is just a bit longer, so it's like a page and a half. And if you render it, you get this enclosure. Yeah? And then if you press the print button, you can actually 3D print it. So that's something I would like to do as well. So not only make a sensor node, but also have this thing evolve. It's code, so if somebody wants to take it and say, okay, I can make this a lot fancier, feel free to do so. I haven't put it up on GitHub yet, but it will be soon, so this is still very fresh. Ouch. Then a bit about the internals. So if you take the top board, so one of it functions as the external part. So if you look at it this way, so on the outside, we intend to mount the appearance sensor, so for movement detection, and an ambient light sensor, so they have to be on the outside. But the other ones, we can just keep them on the inside. So there's a temp and humidity sensor, a pressure sensor, and for now also an accelerometer, which are a lot of fun sensors that you can do interesting things with. For a microcontroller, so the Fluksometer internally has been using AVR for a while, but well, it's been a couple of years, and now we have all those sexy Cortex M series stuff. The one I mounted over here is an LPC device. It's been out for, I think, half a year or something. The great fun thing about this is that it internally comes with a switch, which means that you can switch it's a crossbar, so you can assign functions, UART, SPI, I2C to any kind of pins. And what I'm doing is left and right exposing, that's why you see all the strange zigzag traces exposing all those pins. So if you make a daughter board, you can just, in software, make certain connections by software in the crossbar internally in the microcontroller, and you can can almost reassign any pin from GPIO to I2C to UART, etc. There are a couple of course, fixed pins, for example, for the oscillator, etc. So you can't move those around to any pin, but most of them are freely available. Most sensors are also I2C, so it's actually just a bus, and you just hook up everything via I2C. I also wanted to have a good bit of debugging. So what I made is a third board. So the second board is actually the radio internally, and on the back you have the battery and the antenna. And then you have the third board, which is actually a debugging board. And if I get the right headers, which are still in the mail, you can just put them in between the two other boards, like a sandwich. And you can do introspection with that board into your microcontroller. First of all, you can do ISP, so you can program it. You can also take traces, live traces from your application. And it's also got a JTAG and a serial wire output, serial wire debug output, which comes standard on all Cortex M series chips, which means you can do some very nice debugging, setting breakpoints, etc. I haven't tested it yet, so the firmware upload works, but the JTAG still has to be tested, but I don't expect too many difficulties over there. So that's that. Then back to the Fluksometer. So this is the latest version, it's the B version, and it's got actually a new sensor board with a radio that is compatible with the one on the sensor board, so we can actually have some communication between the two, and hence the title of the talk. So we can actually have this Fluksometer, besides having it measure electricity, gas, and water consumption, also have it as a hub, a telemetry hub for these kinds of nodes. The protocol that has been supported up until now is just in the driver, so there's no application level stuff on it, but it's Jeenode-compatible, which some of you might be familiar with, and that is intended. It's intended to stay that way as well. So this is the Fluksometer. So besides doing this hardware stuff, there's a ton of software still to be written, which is something I'm currently working on. So basically what I would like is that if you have such a sensor node, you have pairing, which means that you can put the Fluksometer in pairing mode and it will start listening on a special or a dedicated channel. And then if you just restart your cube, it will go into pairing mode and it will do auto provisioning of all the sensors that are on your cube and just provision those. We need to have, so that this is relegated to a dedicated bootloader inside the Cortex or inside the cube. And then you have support for over-the-air firmware upgrades. We don't have the self-descriptive packets, but we want to have a JSON format that describes what's actually being sent by a specific sensor node. And once we have that, we can make a cube daemon that can do automatic decoding and encoding based on that JSON format. And then, since we want to have it Internet of Things style, we're already, or we intend to publish it on an embedded MQTT broker, which has been present in the last firmware upgrade for the Fluksometer. So that's already in there. It's a Mosquito, which is an MQTT broker, which is going through a standardization process right now inside PAHO, if I'm not mistaken, so the Eclipse Foundation. So that's how the FLM could work as a telemetry hub. And this is some doing it in action, so I just stuck it to my fridge. So this would be nice, except that I'm a bit worried that my kids will take this and start playing with it. So that's going to be the whole purpose. Then again, I could put like a dozen on the fridge and just hope that they won't at least keep one of them or don't touch at least one of them. But so that's a bit the idea of the cube. So it's very much still a work in progress. This is a really basic and an alpha version, but I hope it will evolve into something nice. So yeah, so if you feel free to participate if you've got questions. Well, you know where to find me, and I'll be posting this the current firmware and the SCAT software, or the SCAT description of the enclosure will be posted to a Cube repository very soon. So I expect this week or next week will be posted. So that's about it. Questions?
Do you have any idea what a rough estimate on the lifetime of the node from the battery perspective?
Sandy. Not yet, but it should be plus 1 year, and that's should be a conservative estimate. It all depends, of course. It's not really the sensors that will do a lot of the battery consumption, but actually the radio. So if you say, okay, I want to have updates every 10 seconds, then it won't last for a year. If you say 5 minutes, which is okay for a temperature reading or a pressure reading, etc., then you should at least get 1 year. That's the aim, at least. Yeah. So we'll see. Depends how good we can write the software. It also means that you have to do a lot of well, not a lot, but you have to start out with an architecture that puts the microcontroller into a deep sleep mode by default and only wake it up. So that's something that's been taken care of already. It has to be validated, of course, into the design. So most of these sensors, or the relevant ones that need to be able to wake up the microcontroller, like the PIR, the movement detection, they're already hooked up to the one pin that can take it out of a deep sleep mode. And if you put this Cortex into a deep sleep mode, you get about like a 1 microamp of consumption. So it won't be the arm that's doing the consumption. But we'll see. And the radio is also 0.1 microamp if you put it into sleep. Of course, if you wake it up and you start transmitting, it's like 20 milliamps. And that's also one of the reasons we use the Jeenode stuff, because it's well, the protocol is really very tiny. If you go into these tiny kinds of low power stuff, every bit that you send is costing you dearly. So every bit that you can spare and not send is giving you battery life. So that's and you make trade-offs, of course. The maximum packet size will be about 64 bytes. The header is only 3 bytes, and you put a bit of preamble there, so you're only sending a couple of bytes for every packet that you're sending. But it remains to be seen how far we can take it.
Could you maybe tell us a bit about the radio? What kind of frequency it uses, or what kind of protocol, and also does it integrate with other home automating systems like X10 or other protocols?
Well, the radio will be an evolved version of the one that's being used by Jeenode, so the RFM12B, which is pretty popular in hacker circles. So it's pretty low cost. It's on 868. It's frequency shift keying. With the new version of that radio, you can do some de-whitening and stuff like that, or Gaussian FSK. but we'll probably just put it in FSK and maintain as much compatibility as with the current Jeenode configuration. So not too much fancy stuff in there, but it gets the job done, which is okay. And then for compatibility, you have a plethora of standards these days. You have Zigbee and Z-Wave and stuff like that. So what I also like about the G-Lab stuff is that it's fully open. You don't have to go to a special interest group, sign an NDA, and blah 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 before you get the spec. So it's fully open. You write your own driver, and it's just SPI based, and you say put it in this mode, and I'll send it out in this way, which I find great. So if you want to make an open device, that's the way to do it. Compatibility, well, you can always, once you have it in MQTT, you can just it will be in JSON on top of MQTT, so you can parse it any way you like. If we one day make a version of this where you can do control, then it's just in MQTT that you send on a certain topic, saying, okay, put this on, put this off, and everything else is software. If you want to hook it up to extend to something else, then yeah, you have to put in a bridge or it's pure software. Yeah.
Okay, my question was, because you advertise it as a tool for measuring water, gas, and electricity consumption, I don't see how these sensors can measure water, gas, and electricity consumption.
So this one already measures. This is a Dutch smart meter. So you can also already hook it up directly to a Dutch smart meter, and it will decode the P1 port of the Dutch smart meter. There are also on the other part, on the top there, on the screw terminal, you can connect current clamps. You can then connect read contacts. There are some more sensors in the pipeline, like an optoreflective sensor. That's almost finished. And so with the Fluksometer, we already do that. And now the question is, how can you extend it? So if you want to measure temperature, okay, well, this Fluksometer is most of the time sitting in the basement, so you can measure the temperature of your basement or run a very long wire. But if we can just extend it, so if you see here, there's a radio module over there, a radio module with an antenna. And then if you have this cube and you put it in your living room, then it can just talk to the Fluksometer. And this one can already just connect it, make these readings available, and then yeah, off you go to the internet. So that's the whole chain.
Is there a plan for other sensor boards, like if you want to connect external sensors, like to put them in your fridge or so?
What do you mean putting in your fridge?
If you want the internal temperature, I'm not sure if you want to really stick the whole cube in the fridge.
Well, it would be a nice experiment. It would be a solution to my kids tampering with the setup. Wait, so this is actually what you're seeing is version 1. Revision 1. Revision 2 will already have some holes here for extending the I2C bus. So for having a better hackability. So you can leave it open. That means that it will have some open holes for the temperature sensor, but you can also close it and have an external I2C sensing. So the range will be limited. So it's a meter, 2 meters, perhaps in the best case 10 if you perhaps lower the clock rate of the I2C bus. But that's one way where you could easily extend the cube. If you want to add even different sensors, there's always, of course, a way to open the sandwich and put another board in between, and then you can extend it with even more exotic stuff. But the basic idea is, okay, you take this cube and you already have the 5, 6 sensors for free. You don't have to start extending the board, and you have a small sensor node, but if you want all the sensors, then you get a board like this, and then you have to think, okay, how am I going to put this in an enclosure? You don't know, and then okay, then it's just over there gathering dust. So this would be be perhaps an answer to this.
I have a question about distance, because what we're talking, it's inside a home or an apartment. So how far you can place such sensors? And you also mentioned firmware update. So is it speed and reliability is enough?
Speed and reliability in what sense?
So this radio channel will be enough for doing update of your firmware. So it's reliable and speed is enough to do it fast. So it not take half a day.
So the ARM chip is limited, if I'm not mistaken, to 16 kilobytes of firmware. So even if you use a pretty slow connection, like the basic Jeenode one is about 50 bit per second at full rate. But okay, you have to have packet processing, etc. So you're never going to hit that rate. The range is one of the reasons we opt for the 868. And we stay out of the 2.4 because that's terrible for your attenuation. So the 868 it can travel through a couple of walls and still have reasonable range. Everything depends, of course, on your radio. So what your link budget is. So how powerful can you transmit, and what's your noise floor. But these newer chips, they can go up to 13 dBm of transmit power, and the receive at that rate, if I'm not mistaken, is minus 105. So if you have about a link budget of 115 dBm, which should be okay for at least going through the full house. Well, depends on your house, of course. If you have a castle, that's different. But for my house, it would be okay. So, does that answer your full? Okay, for the firmware updates, sorry. What we're building is something robust. So basically, the cube asks the Fluksometer, do I have to upgrade during boot? And if it says yes, an upgrade to this firmware, it's up to the cube to collect all the packets. So if packets get lost, it will just retry until it gets its full firmware. If it fails, it will try again. So that's in the bootloader. Then it's the task of the bootloader to get it working again. Yeah, and it will try, or it will go dead failing. So if you go for an upgrade and you power up the Fluksometer for the next half a year, your battery will be dead because it will try catching up with the new firmware. There's an exponential backoff in there, but yeah, it's either one or the other. So yeah.
Is it OpenWRT running on the brew board that you showed? Yeah, this one is it. Can you specify which system on chip you use, and how do you interface the your red board with the blue board? Is it UART or something else?
Yeah. So yes, this is indeed OpenWRT. Every Fluksometer has been pre-production alpha version, and production has always been OpenWRT. I did the migration to attitude adjustments in the second half of last year. So that firmware went up in October. The connection with the sensor board is via SPI, so SPI based. Yeah, it's bit-banked SPI, but that's enough because you don't have that much communication between the two. So a lot of processing is being done on the sensor board for the clamps, etc. We're sampling this at 600 hertz or something per, or 666, so the number of the devil. And then if you go to 3 phases, it's 2 kilohertz. But that's all locally on the AVR, and what you get back every second is a reading of your real-time consumption and a counter. So it's SPI communication between the sensor board and the main one, and it's OpenWRT, now AA, on the main board.
Okay, 2 quick questions. Is there any sort of encryption between the cube device and the Fluksometer? And second, is there a way to send a command to the box, or it is just a node that sends it back?
So for the encryption part, by default, right now we won't have encryption, but in the bootloader there will already be the facilities to download a 16-byte key. So there you have like a limited attack vector if it's in plain. Well, in plain, your key is sent over the air. So that's a limited attack vector. But once it's in there, it will calculate a CRC or a hash of the thing. And once it connects again, it will say, okay, I have this hash of the key. So it won't retransmit the key back to the Fluksometer to check it. So that's only once that you have to go there, and then it's already the facility is already in the bootloader. But it's the chip itself or the radio. Will by default right now not be encrypted. And then the second question was, for actuation. So the thing about actuation is that if you have to, if you want to have it very reactive, you have to keep on your radio, which is of course a drain on the battery. There are some intelligent ways of handling this. That's by using putting your radio to sleep and only listening every couple of seconds or every minute. But then you have to have good synchronization. But this is something that can be done. But let's say for the start, we just start with a sensor node that senses all kinds of things and then uploads it, and especially just get this the lifetime or the battery life, get it as high as possible, and then in the second phase we can look for actuation. Thank you.
So, I think, are you staying for the session at 2:30? At 2:30 we do have like a participant-driven discussion. So I think if there are more people interested into Fluksometer, I think at 2:30, between 2:30 and 4:30.